What about electron configuration for ions? For ions, what you have to do is take away the electrons from the last or the highest energy orbital. So let's look at sodium one more time. And if you recall, sodium has a +1 charge. And the plus means lost 1 electron. So it's 1s2, 2s2, 2p6, 3s1. This one is 1s2, 2s2, and then you're asked, okay, where is the electron going to come out from? Well, the rule is this way, is if you add an electron or take out an electron, so I'm going to write it here on the top. Okay. Take out, you will never go wrong from here. Take out or add electrons or electrons to the highest energy orbital. Okay, which one in this case would be the highest energy orbital? Would it be the 2p or the 3s? The 3. That tells us it's at the third energy level. This is at the second energy level. So what that means is when you remove the electron, you actually end up removing it from this one. Remove this electron. So therefore, you're left with 1s2, 2s2, 2p6. And you're going to learn in the next lecture that leads to the octet rule, which is again reflected on the orbital diagram, just to show it here, but be able to do it. Three S1. So you go up, down, up, down, up, 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 down, 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 and then up. But for instance, here we took away the electron from the 3s1. It's going to look like this, except the 3s is empty. So you might ask, should I still draw it if it's empty? And the answer is no. You can just delete it or not draw it at all. I put it here so I can show you as a comparison how this one is missing. If you add an electron or electrons, you add them to the highest energy orbital. So for example, if I have this question, if I have S, and here it's S minus 2. Minus 2 means gained 2 electrons. One S2. Let's just use the abbreviated method for this. So the abbreviated method is, this would be, let's look at our periodic table. Here's S. Last noble gas is Ne. And then it's going to be 3S2, 3P4. Okay, so the question is, well, where do we add those 2 electrons? Well, this is where you add them, to this one. Can it fit 2 more? Of course it can. This can This one can take up to 6. So you have 2 more. So you add the 2 electrons to this 2p, and it's going to be an E 3s2 3p6. Very well. I might just fix this. And your orbital would look like this. So this is a 3s, and this is the 3p. For the 3s, it's up, down. 3p4 is up, 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 down. So it's diamagnetic, paramagnetic. But when you added the electrons to it, it becomes diamagnetic because they're all paired now. So up, down, up, 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 down, down, and then down. Notice the difference between them. Okay. Exceptions, exceptions, exceptions. One of the reasons why some students struggle with chemistry, let's say more so than biology, or sometimes more so than physics, is because one of the reasons is exceptions. Exceptions are very, very sometimes disappointing to humans because we finally developed a pattern, and then nature, throws a curveball, and we're like, okay, why? But this is nature, and the more you investigate it, the more you actually see how unpredictable it can be. So the explanations can be beyond the scope of this class, but this is what I mean. I'm talking about mainly with exceptions, is you want to look at transition metals and beyond. Okay. So let's look at Fe. Fe2 plus, Fe3 plus. If you look at Fe, and by the way, I might say an exception, but if you remember what this says, you should be okay. This is going to guide you and help you. Remember what the highest energy orbital means. It means the highest n value. So if you look at for the F, and again, we're just doing the abbreviated, so that would be AR 4s2 3d6. What does the 2 mean? Plus 2 mean? Lost 2 electrons. So you might be saying, oh, well, yep, let's take it out from D. Except that that's not your highest energy orbital. Yes, it is true that the 4 fills in first, but this is what we call the 4s is actually your valence, all right? They're what we call the outermost. And it's really, the answer is beyond the scope of this class, but it has to do with what we call shielding and penetration. So we're going to say no. We're going to take out from the 4s before we take out from the 3d. So you start taking out from here. Take out first. So therefore, it's going to be argon 3d6. That means it lost 2. So that's my 2 electrons lost from the 4s2. Well, what about 3? Means you lost 3 electrons. So what do I start taking from? Well, you start taking 2 from here, and then you have 1 more you take out from there. So it would come to be argon 4, sorry, argon 3d5. And here's what I'm going to write so as an explanation. Okay, 2 electrons lost from the 4s, 1 electron lost from the 3d. That accounts to 3 electrons lost. So keep that in mind.